In today's lesson, we'll be talking about qualitative graphs. The lesson is 4.9, Part A and B. The standard is 8F5. The objective is to sketch and describe qualitative graphs. The essential question is, how can we model relationships between quantities? Today, we're going to look at qualitative graphs. We're going to start with acceleration graphs. Acceleration means it goes from slow to fast. In the first graph, it's distance over time. At first, it starts off slow, and then because the line is getting steeper, it's getting faster. That is acceleration. Similarly, this one is also acceleration. The line starts off a little flat, so it starts off slow, and then it gets steep to go fast. In other words, if a line is steep, that equals fast. If a line is flat, that equals slow. Let's look at the deceleration graphs. It starts off steep and then it flattens out. So it starts off fast and then it goes slow. That is decelerating. It's getting slower. In the fourth graph, it starts off steep and then it flattens out. Again, that's deceleration. It starts off fast and then it goes to slow. A stationary graph is one that is not moving. When something is not moving, it's standing still, like a car waiting at a stoplight. Now, constant speed is when it's not going fast and it's not going slow. For instance, a car is driving 25 miles per hour. The lines are straight. These are constant speeds. Example number 1. Examine the distance time graph. Who's walking at a constant rate? How do you know? Constant rate and constant speed are straight lines. So Quincy and Andy are walking at constant rates. So Quincy and Andy because their lines are straight. What does Marcus's graph mean? If you look at Marcus, it starts off flat and then it gets steep. So flat means it starts off slow. And then it transitions to fast. So he started slow and accelerated faster. So maybe he realized he was running late because he was walking too slow and started running. Who is faster, Quincy or Andy? How do you know? If you look at the two graphs, Quincy's line is steeper. Therefore, Quincy is faster than Andy. So Quincy is faster because his line is steeper. Example 2. Examine the distance time graph. Describe what happens at each interval. So from A to B, it starts off slow and it goes faster. Slow to fast is called acceleration. So we're going to call the origin home. So it is acceleration away from home. From B to C, it is a straight line. That means it is a constant speed. And because the line is going away from the x-axis, it is going away from home. From C to D, this is a flat line. That means it is stationary. It is not moving. From D to E, it is a straight line going away from home. So it is called a constant speed away from home. From E to F, this is a straight line. However, it is going down toward the x-axis. So it is a constant speed towards home. Sketching functions, lesson 4.9, part B. Example 3. Alyssa comes home from school every day. The information below describes her journey. As I read through this, I'm going to circle all the times. Alyssa walks to the park 1 block away from school in 4 minutes. She waits at the park for 8 minutes for her dad to pick her up. Her dad drives them 3 blocks in 2 minutes to Jack in the Box. They wait in the drive-thru line for 10 more minutes. Her dad starts to drive slow, then realizes they are running late and starts going faster and faster. It takes them 4 minutes to drive 6 blocks home. Sketch a graph of Alyssa's distance from school as a function of time. So if you look at the graph below, there are no numbers filled out. Let's find out how many minutes we need. So let's add 4 plus 8 plus 2 plus 10 plus 4. That equals 28. So let's count by 2s across the bottom. But because it's going to get crowded, I'm going to skip. So it's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and 40. The distance from school in blocks, let's count by ones. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alyssa walks to the park 1 block away from the school in 4 minutes. So she starts at school. She's going to go up 1 block in 4 minutes. It's going to be up 1 and over to the 4. It says she walks, so that is a constant speed. She waits at the park for 8 minutes for her dad to pick her up. She waits, that means it's stationary, so it's going to stay flat for 8 minutes. So 8 plus 4 equals 12. So I'm going to go to 12, make my dot, and make my line straight. Her dad drives him 3 blocks in 2 minutes to Jack in the Box. So we need 3 more blocks. 1, 2, 3, and we need 2 minutes. I'm assuming it's a constant speed, so we'll draw a straight line. They wait in the drive-thru line 10 more minutes. That's stationary, so we need 10 minutes flat. We are on minute 14, so 14 plus 10 minutes equals 24. So I'm going to go to 24 and draw a flat line. Her dad starts to drive slow and then realizes they are running late and starts going faster and faster. It takes them 4 minutes to drive 6 blocks home. So we need to go up 6 blocks, then we need to go to the right 4 minutes. So I have 1, 2, 3, 4, 5, 6, and then 2 and 4. So I'm going to make my dot here. He goes slow and then faster. So I'm going to start off flat and then make my line steep. So this is a function of Alyssa's journey home from school.